Let's now look at some exam questions in which the normal distribution is used as an approximation to the binomial distribution. The first question is this question 3. This is from June 2009, paper 6. And it says, on a certain road, 20% of the vehicles are trucks, 16% are buses, and the remainder are cars. A random sample of 11 vehicles is taken. Find the probability that fewer than 3 are buses. Now, obviously, this is used with the binomial distribution, okay? So here you have the number of buses, x. The random variable x is the number of buses. The probability of finding a buzz is 0.16, meaning that the probability that is not a buzz is 0.84. And you want the probability that this is not what I want. You want the probability that fewer than the 3 vehicles are buses. So if x is the number of vehicles that are buses, so you want p of x being smaller than 3. So that corresponds to x being equal to 0, 1, and 2. Use the formula for the binomial distribution for all these values. And here you have the result. Then it says, a random sample of 125 vehicles is now taken. Using a suitable approximation, find the probability that more than 73 are cars. Okay, now the value of n increases, and this means that you are now going to be in conditions to use the normal distribution to model this. You know that the mean is given by np. The probability now, basically, you are no longer looking for the number of buses. You are looking for the number of vehicles that are cars. Okay, so the random variable changes. And so does a probability is 0.64 for cars, which means that it's 0.36 for anything that is not a car. The mean being equal to NP equals to 80, okay, more than appropriate to use the normal distribution. The standard deviation is given by the square root of NPQ, so here you have it, and you have everything that you need. The probability that x is bigger than 73 is equal to 1 minus the probability that x is smaller or equal to 73. We went through this extensively on the other lessons, on the test and the play section of questions. So if you are to focus on this, the fact that this is smaller or equal, you know that the continuity factor needs to include the value that is slightly above this one, so it goes to 73.5, okay, minus the mean divided by the standard deviation. This is going to give you the z value, which is a -1, and you already know also what to do when this happens. You have to do 1 minus the probability of finding the corresponding positive z value, then go to the MF19 to get the corresponding probability. The z value was 1.211, 1.2 is over here, 1.21 is over here, and the last digit, the 1, you have to add 2, okay? So actually you have to add 0.0002. So 1.11, 0.8665, you add that 2 to the last digit, so it's going to be 0.8667. Which rounded to 3 decimal places is 0.887. Let me just... Yes, I was looking at the wrong place. It's the z value is 1.211. So is 0.8869, add 0.0002, so it will be 0.8871. Okay, 8871. So 887, 0.887 rounded to 3 decimal places. Next question is this one over here. Is from paper 6, November 2007. And it says, on any occasion when a particular gymnast performs a certain routine, the probability that she will perform it correctly is 0.65, independently of all other occasions. Find the probability that she will perform the routine correctly on exactly 5 occasions out of 2. Okay? So this is obviously modeled by a binomial distribution in which P is 0.65, Q is 0.35, X is the number of occasions in which routine is performed correctly, okay, N is 7. So if you want the number of occasions to be exactly 5, this is given by the formula that you know for a long time. Just plug all of this in the calculator and you have here the corresponding probability. Now, the number of trials is going to increase. On one day, she performs the routine 50 times. Use a suitable approximation to estimate the probability that she will perform the routine correctly on fewer than 29 occasions. Okay, so now you have n equals 50. X is the number of occasions in which the routine is performed correctly again. But now we are going to calculate the median, by doing n times p, 50 times 0.65, that's 32.5. This value allows you to use the normal distribution is bigger than 5. To calculate the standard deviation is square root of npq, so here you have it. You want the probability that the number of occasions in which the routine is performed correctly is smaller than 29. We have to use the continuity correction. This is smaller, just smaller, not smaller than equal. So the value that you use stands a little bit to the left of this. So it's going to be 28.5 minus the median divided by the standard deviation. You have here the z-value is a -1. So what do? 1 minus the probability of associated with a positive z-value. Go to the MF19 and find the probability associated with 1.186, 1.18. 1.18 is 0.8810, and now add the last digit corresponding to 6, which is, let me see if I don't mess up like I did in the previous question. So 1.1, it's 12. So if you add that over here, you're going to end up with 0.8842, right? No. Let me see the value again. 1.186, 1.186, 1.186. Yes, that's it. 0.88, you have to add 12 over there, so 22. 8.8822 rounded to 3 decimal places is just 1.118. Of course, this corresponds to 1 minus 0.882. Then, on another day, she performs a routine n times. Find the smallest value of n for which the expected number of correct performances is at least 8. So what is this? This is giving you the expectation. And the expectation equals to np. You already know p. P is 0.65. And you want to get the value of n. You want to get the smallest value of n. All right, so you know that the expectation is 8, so work this out to figure out n. N is 12.3. So the minimum number of times for her to be following these conditions is going to be 13 times. 12 is not going to be enough. It's going to be 13 times. Last question. Spring 2010, question paper 61. And it's question 5. In the holidays, Martin spends 25% of the day playing computer games. Martin's friend phones him once a day at a randomly chosen time. Find the probability that in one holiday period of 8 days, there are exactly 2 days on which Martin is playing computer games when his friend phones. Okay, once again, this is an example of a binomial distribution in which x is the number of days in which Martin is playing computer games. The probability is given there is 0.25, meaning that the probability that he is not playing computer games is 0.75. You have a total for the first question of 8 days, so n equals 8, and you want to know the probability that x equals 2. Okay? So that is straightforward. It's just applying the formula, and here it is. On question 2, it asks, another holiday period lasts for 12 days. State with a reason whether it is appropriate to use a normal approximation to find the probability that there are fewer than 7 days on which Martin is playing computer games when his friend phones. Okay, so let's use now this new value of n multiplied by the probability. And we got what? We got 3. I'm sorry, but the condition for you to be able to use this approximation is that this product is at least 5. Well, 3 is smaller than 5, so it's not appropriate. On the last question, n is going to increase. Find the probability that there are at least 13 out of a 40-day holiday period on which Martin is playing computer games when his friend phones. So n is now 40. Okay, so if n is 40, obviously now the value is going to be 10, which is bigger than 5, so we can use the approximation. Let's just calculate the standard deviation first by using its formula. Here it is. And we want the probability that the number of times in which playing computer games and the phone ringing coincides is bigger than 13, okay? Bigger or equal to 13. So this is the same as 1 minus the probability that x is smaller than 13, okay? Smaller without an equal, so the continuity factor demands that the value that you use is slightly below this, so it's going to be 12.5, okay? Minus the mean divided by the standard deviation. You have this z value is a positive 1. You can go straight to the Math 19 and find it. 0.913, 0.91, and then you add 3, which is 8. So this is going to be 0.8194. Okay, so 0.819. You do 1 minus that, and the result, corrected to 3 decimal places, is 0.181.